Question 5. So in the question, they're telling me that a carbon atom has got 6 electrons, 7 neutrons and 6 protons. Okay, so I'm just going to highlight those. And now it tells me to state the mass number of this carbon atom. So I know that the mass number of an atom is made up of the protons, the mass of the protons, plus the neutrons added together. So they've told me it's got 6 protons and 7 neutrons, so therefore the mass is 6 plus 7, which is 13. Give the electronic configuration of this carbon atom. So the electronic configuration depends on the number of electrons it has. So this one has 6 electrons in total, and I know that my first shell, my electron shell, can only take 2 electrons, then that one's full up. My next shell could take 8, but actually I've only got 6 in total. So my next shell must have 4. 4 plus 2 is 6. So that would give me my electron configuration of 2, 4. 2 electrons in the first shell, 4 in the next shell. Diamond and graphite are both forms of carbon. In both substances, the carbon atoms are held together by covalent bonds. Describe what is meant by a covalent bond. So I know that covalent bonds mean that in that instance I have 2 or more electrons are shared between atoms. So that is a definition you just need to remember. It's where we have 2 or more electrons shared between atoms. Figure 12 shows the melting points of 2 substances A and B and the abilities of the substances to conduct an electric current when solid and when molten. So here we go. So here's substance A. That one's got a melting point of 35 degrees. That's quite low. That's lower than water. And can it conduct electricity when it's a solid? No. Or when it's a liquid, when molten? No. B has got a high melting point, so 101 degrees. Can it conduct electric current when it's a solid? No. When it's molten, so as a liquid, yes, it can. So one of the substances has an ionic structure and one has a simple molecular covalent structure. So A and B, one is ionic and one is covalent. So explain. Okay, so we've got a point and explanation question here. So I'm going to use PE. In terms of bonding and the forces between particles, okay, so not between atoms, between particles, the relative melting points and abilities to conduct the electric current of substances A and B. Now this is worth 6 marks, okay, so I have to write down at least 6 different points. Okay, so let's look at the question again. Explain in terms of bonding and the forces between particles, the relative melting points and abilities to conduct electric currents of substances A and B. Okay, so I'm going to look at substance A and B, and they've told me that one is ionic and one is covalent. So I'm going to start with covalent. I'm going to put a little subheading to make it nice and clear. So I'm going to start with covalent substances, and I have to know here that actually substance A is covalent because we've got this low melting point and it doesn't conduct electricity. So I'm going to write down first point here, and that is a point, and I will get a mark for it, is that substance A is covalent. Okay, so that's my first mark. Now I need to split this question into melting points and being able to conduct electric current. Okay, so I'm going to start with melting point. And remember that in this question, I've got to answer it in terms of bonding and the forces between the particles. So let's go back here. So A is covalent. It's got a low melting point. Okay, so it's low because the molecules have weak forces between them. and I can call those intermolecular forces. So what I'm looking at here is if I've got a liquid, okay, there's my liquid, not very good liquid, but what I'm looking at is the forces between these different atoms, okay, between the different molecules here. And so those forces are quite weak. Those intermolecular forces are weak. So that means that I only need to give a little energy to separate the molecules. Okay, so I just give them a little bit of energy, a little bit of heat energy, and then the molecules will start to separate because there are weak forces holding those different molecules together. Okay, so that's the melting point. So now let's look at the ability to conduct. Okay, so can't conduct as no ions. Remember that to be able to conduct electricity, I either have to have free-flowing electrons, as I might in a metal, or I have to have ions, so charged particles, so minuses or negatives that can flow from one side to another. Here I've got covalent substances. I don't have any positive or negative, I don't have any ions, and therefore it can't conduct because there are no ions. Okay, so now I'm going to do the same, but this time for my ionic substance. Okay, so I'm going to put substance B is ionic, and I'm going to do exactly the same as I did before. I'm going to do the melting point first. Okay, so the melting point here is high, and that is because I've got strong forces between molecules, okay, and they are in fact electrostatic forces. They're electrostatic because I've got positive ions and I've got negative ions, and so there's a little kind of relationship that forms between these two, and we call them electrostatic forces. And so what does that mean? I need a lot of heat is needed to overcome these forces. Okay, now I go on to my conduction. Okay, no, it can't conduct as an ion, as a solid. Unable to conduct as a solid, as no free ions. Okay, so I'm running out of room here. I'm going to have to just push my paper up and do it at the bottom here. But can conduct when molten as ions can move. Okay, so that's when those positive and negative ions can flow from one side of the liquid to another.